Hey guys, it's Mrs. Shevchuk, and today we're going to be looking at how we can solve systems of equations using the elimination method. So this will involve first eliminating one of the two variables in order to solve your system. First things first, I'm going to have you pause the video and try the two warm-ups on page 12 in your packet, and then push play when you're ready to check. When you simplify each of these expressions, hopefully you notice that one of the variables canceled out. In the first one, our y's canceled out because we had a 5y and a negative 5y, which left us with just 8x. And on the second one, we had to be sure to distribute that negative first to both terms within the parentheses, and then combine terms. And again, we see we had a positive 6y and a negative 6y, thereby those cancel out, leaving us with negative 2x as our simplified expression. We're going to use this idea today as we solve some systems of equations. Previously, we've learned how to solve systems by graphing, we've used equal values method, and we've used substitution. Another method that we're going to use today is called elimination. This method involves eliminating one of the variables by combining the individual equations by adding vertically. Once you have one equation with only one variable, either all x's or all y's, then you use your solving skills. The steps we'll use to eliminate are listed on the screen, and we will come back to step 2 once we get a little further into some examples. The first example is on page 12. We're going to use elimination to solve the system of equations. So we lined up our variables. I've got my x's above my x's, my y's above my y's, and all I'm going to do is I'm going to add these two equations together. In doing so, what happens is I end up with 8x, and then the 5y and the negative 5y cancel, and I have 16 on the right side. When I solve for x, I find out x is 2. That gives me the x coordinate for my solution. And now I just need to substitute that back into one of the original equations to solve for y. So I'll say 3 times 2 plus 5y equals 11. And I have 6 plus 5y equals 11, 5y equals 5, y equals 1, and that gives me the y coordinate of my solution. And so my solution of 2, 1 is the point where these two lines will cross. All right, now it's your turn to pause the video. Try using the elimination method to solve the second systems of equations. Push play when you're ready to check. When you add the two equations vertically, you eliminate your x's, leaving you with a y value of 5. Then you substitute that back into either one of the original equations. I use the second one. And I solve for x, giving me x equals negative 7.5. So the solution to this system of equations is negative 7.55. Right? When you look back at these two problems, what do you notice about the variables that got eliminated? How were we able to do that? Hopefully you're seeing that they both have the same coefficient, but opposite values. We have 5y and negative 5y. We have 6x and negative 6x. The other thing that works out really nice here is both of these equations in each of the systems are written in standard form. And that's going to make it really nice for us as well. Now let's take a look at example 3 on page 13. It tells us to use the elimination method to solve this system. But when I look at it, adding these two equations together isn't going to eliminate either of my variables, is it? So what else could I do? What could I do to this equation that would allow me to eliminate one of my variables? Well, one thing that would work really well is multiplying this whole equation by negative 1. In doing so, I'll end up with negative 5x plus negative 6y equals negative 6. And the reason that's helpful is I can now see I've got a positive 6y in my first equation, a negative 6y in my second equation, and now I can line them up vertically and add them to eliminate one of my variables. When I do that, I'm left with negative 2x My y's cancel out, and I have 24 on the right. When I divide each side by -2, I'm left with x equals -12. All right, now I substitute that back into either one of my original equations to solve for y. 3 times -12 plus 6y equals 30. I've got -36 plus 6y equals 30. If I add 36 to both sides, I get 6y equals 66, y equals 11. So my solution to this system is -12, 11. And again, always a good idea to plug it back in to check that it works with both equations. Pause the video, try the problem on page 13, and then push play when you're ready to check. All right, when I solve this, I get a solution of -1, -2. If you got the same, keep watching. If you made an error, pause the video, go back, and retrace your steps. All right, now it's time to take a look again at that second step that we bypassed the first time. All right, sometimes you're not going to be able to eliminate one of the two variables, like in the last two problems, without doing something different to the equation. So sometimes step 2 is you're going to have to multiply one or both of those equations by a constant or a number so that either the x variable or the y variable can have the opposite coefficients. We want opposite coefficients so we can add them to cancel them out. So looking at the example on the right, what could we multiply one of the equations by in order to cancel out the x's or the y's? Well, I could multiply this second equation by -2. And if I did that, I would end up with -4x plus 6y equals -18. And then I could add that to this original equation, and that would allow me to cancel out those x's, solve for y, and then plug it back in. So multiplying one or sometimes both of the equations is going to be a helpful strategy as we go forward. Here's an example where we're going to need to multiply first. When I look at this equation, I don't see any coefficients that are opposites. So I'm going to multiply, I think I'm going to go with my second equation, and I'm going to multiply it by -2 so that I can end up with a coefficient of -10. So I have -10x, -2 times -3y is a positive 6y. And I have -2 times -7, that's a positive 14. And then I'm going to add that to my first equation up above. I'm just going to recopy it so that they're lined up here nicely vertically. And my x's cancel out. I have 11y equals 44. Divide both sides by 11, and I get a y value of 4. Then again, we plug that back in. I'm going to go to this first equation, plug 4 in for y, and solve for x. 10x plus 20 equals 30. 10x equals 10. X equals 1. So my x value is 1. My y value is 4. My solution is 1, 4. All right, time to try 2 more on your own. Pause the video, work out the problems on your page, and then push play to check. Be sure to show all your work as you're going. How'd you do? If you have any questions on these, make sure you reach out to your teacher. Otherwise, looks like you're ready for more practice. Thanks for watching.